still got about a minute or so. I have to tell you an interesting story. Over the weekend, I bought a one of those really tiny mini computers for my daughter. It has an Atom processor on it. It's basically the same as a netbook, except it's a quote unquote desktop computer. It's small enough that most people can mount it to the back of a monitor, so the computer is completely out of the way. Now with an Atom processor, it doesn't really have a lot of juice. It doesn't have a lot of processing resources. So my daughter always complains, the computer is too slow, it's not responsive. I click here and then I have to wait 30 seconds before something happens. So yesterday, just out of curiosity and also to test my NVIDIA driver for Linux, I put in my live distribution, which is what I use for this class. So I pop it in and then rebooted the machine using the live image. And the whole thing was running out of my little SD card, my 4 gig SD card. It was not even a high-speed one. I think it's a class 4 or class 6 SD card. It's an older one, so it's not really fancy. And guess what? The computer became super responsive. My daughter looked at it and go like, "Wow, this is like a new computer." So from now on I told my daughter, if you want to use Linux, just pop one of these things in, and reboot the computer, and it will reboot into Linux. And she already knew how to use OpenOffice and stuff like that, and in Windows. So switching back and forth between Linux and Windows 7 was not a problem. At first, I thought you would complain and say, "Oh, this is completely different, in a different environment. Things are at different places. I don't know how to use it." Not a problem. Okay, the moment I switched, she was navigating in it, playing with the background images and stuff like that. Not a problem at all. So for those of you who are interested, this is a live image of Linux. It will fit actually on a 2 gig SD card. I have a 4 gig around, so that's why I put it onto a 4 gig one. And the way to do it is to go to an image, and I can show you a little bit of how to do that, just in case some people are interested. So what you do is you go to the power server, and that's a good reminder that I need to turn off my ringer too. So you guys are very good, with reminding me every single time, because I really hate to be the first one. All right, so this is the power server, and the URL is power.arc.losreals.edu. It's mostly for our web-related classes, but I also put my stuff here. And if you look down here, Dr. Text Debian Live CD, the second link here, that's the image. It's an ISO file that you can download, and you can do 2 things with it. One, you can burn it onto a DVD-ROM, and then use a DVD-ROM to start up a computer. You'll get to this environment. The second thing you can do is to quote-unquote burn it onto an SD card. So this way it is reusable, it's smaller, and it works exactly the same way, except it is faster. An SD card works faster than a DVD. Why?
Solid state.
It's solid state. Okay. There's no need for a head to move back and forth. There's no rotational delay. So that's why it works faster on an SD card than it does on a CD or DVD. You can use it for several things. One, you can use it the way that I use it in the class. I need a second flash drive to save all the files that I saved in the class, but that's pretty easy. The second thing you can do with it is to use it as a rescue disk. In other words, if your Windows partition gets infected to the point that it won't even start up, you can use this mechanism to at least boot your computer and actually retrieve the files from the file system. Now with OpenOffice already installed, you can also open files that are currently on your computer, even if Windows would not start up. For instance, I can do something like this. I can look at my files, and you can see that it can see the Windows partition here. This is the Windows partition on this particular machine, and I can go to users and rescue files if I wanted to. So let's see what other people have done on this computer. You did not hear that from me. I like how many of you have watched The Hunt for Red October? It's an old movie. Okay, you read the book too. But in the movie, my favorite scene was not one of those, the sub, battles. It was, what's his name?
Jack Ryan.
No. The old guy.
Sean Connor.
No, Earl Jones. James Earl Jones. That's it. So my favorite moment was, when he appeared behind that person, who prematurely detonated the torpedo, and he said, "I was never here." Oh man, that was the best scene of the whole movie to me. That was the best scene. And you guys know that he's also the voice of Darth Vader in the first 3 movies. Yep.
But then you're gonna have to cut that off your.
But that's the favorite part of this lecture too. Yep. Go ahead.
So if there's different versions of Linux, which one do you use and why?
I use Debian, because Debian is a little bit more stable, and I also like it because it doesn't cut off some tools like Ubuntu does. The installer of Ubuntu, for instance, is very limited because it's intended for regular end users. But the Debian installer actually allows you to install it in a server configuration, so I like it better. One of my home computers is Ubuntu, and the new version of Ubuntu has switched to GNOME 3 as the desktop environment, and that's just a beast. I mean, I do not like it at all, and many people agree. And if you use Ubuntu, you don't really have much of a choice. That's the default desktop. But in Debian, I can use XFCE4. This environment is called XFCE4, which is really kind of quote unquote classic compared to GNOME 3. And you can also see how little resources it takes. I mean, this computer or this environment would run with less than 300 megabytes of RAM. So that's pretty frugal. So that's a little bit of the background of the environment that I use in the class that I also use to do screen recording. And let's double check and make sure the screen recording is recording from the right channel. And it is. Okay, very good. All right. First thing first, I want to talk about the homework assignment first, the homework that is due on Thursday. Okay, I'm not going to do it in the class, so don't worry. And for those of you who have done the homework already, you don't want me to do it for the rest of the class, right? I'm not going to do that, but what I will do is to give you an example of how to do the homework for people who might have some questions about, okay, but how am I going to do this homework assignment? So what I'll do is I'm going to give myself another homework assignment. And remember, this is just an in-class assignment for myself to demonstrate, how to do the homework. Yes?
Do we have homework due for today too?
Nope, we do not have any homework to do today.
So, it was Thursday, the one we were
Yep.
supposed to do.
Yep, that's Thursday, and that's next Tuesday.
The email you sent said Tuesday.
Oh, I did. Sorry. Yes. See how good how good a liar that I am. I don't even flinch, when I lie. Did I say that? Of course, when I said I was a good liar, that's a lie too. Okay, so what I'll do is I'll give myself, a homework similar in terms of nature to that, but a lot simpler because I don't want to do your homework assignment. So I'll just make it a little bit simpler. So this one is a whole lot simpler, but in terms of the nature of the homework assignment, it is similar to what you have to do. Okay, so in your homework assignment, the first sheet has the algorithm, except in your case, the algorithm is a little bit longer, and I think I forgot to bring my row sheet again. Okay. I have to take rows at some point, but let's focus on this one first. So this is our algorithm, and I have also labeled the sheets, differently in the homework assignment. So the first one, I would rename the sheet and say, in this case, y equals 0, and let's say in this one, I'll rename it as y equals 5. So when you look at sheet 1, it has the potential of changing y to either 0 or 5. And if you look at the name of the sheets, which appear as tabs at the bottom of the screen, they show you what I want the algorithm to accomplish. So what you need to do is to figure out what would be the initial value of x to make that happen. Is that okay so far? Any questions? So in terms of this homework assignment, or in the case of this assignment, I can just do the whole thing for you. So on this sheet, I want to make the initial value of x so that after this algorithm, y equals to 0 at the end. And to make that happen, I need one column for comments because we have conditions in the conditional statement. We have line number, so I can keep track of which lines I execute in this case. And then I also have x and y as my variables. X technically is not exactly a variable because I'm not changing the value of x when I execute the algorithm, but y does. So what you need to do is to tell me what is the precondition of x in order to accomplish what I want to do here, which is to make the value of y equal to 0. Question?
Yeah. So you're saying we could just choose any x that's below 3, our choice, and then...
Exactly. In this case, any value of x, below 3 is fine. So you can pick, there's an infinite number of values you can pick in this case. 2, 1, 0, 2.5, they all work in this case. Okay? But that's the precondition. This is before we execute the first line of code. So you have to tell me that x has to start with a value of 2. Y technically does not have to start with an unknown value. But since I did not tell you otherwise, you can start with anything. Just don't give me a blank space here. It can be unknown, can be 200, can be 20, because y will be overwritten anyway by the algorithm. So the first thing we do is to go to line 1. Line 1 does not change anything, but it does test the condition x is less than 3. So now you have to tell me x is less than 3. Is it true or is it false? Because x is 2, 2 is less than 3 is true. When the condition is true, you go to the then branch, which in this case is just line 2. So we go to line 2. Line 2 does only one thing. It is an assignment statement. We evaluate the right-hand side, which is a constant of 0, and then we change the left-hand side with that value. And that means y is now changed to 0. And after that, we are done, because you take one branch in a multi-branch conditional statement, and you're done with the whole thing. Yep.
It's pretty trivial, but do you have to put is in between did it say like x is less than 3 is true, or can you just put t is true?
You have to state what condition is true, but you can say, instead of is true, you can use an equal symbol if you want to.
Okay, but you have to have something there.
Yeah, you have to, or even that is fine too.
Oh.
But you do have to repeat the condition that you are evaluating. Just in case, in the case of multiple conditions, I want to make sure that you are evaluating the correct one on that line. Okay. Are there any questions about this assignment? Yes?
Would you not put like a question mark for the x values?
No, because if you put an X here, or if you put a question mark here, there's no way to evaluate the comparison. You cannot tell which way it's going to go when you evaluate it. So it has to be a known value for X. X must start with a known value.
Yes, yes.
So it cannot be a question mark.
Right, but on line number 4, you have 2 for underneath where it says line 3, 1, and 2. Right, that value there, should that not carry over to 2?
Yes, but I also said in the class, the shorthand is not to write anything if the value is preserved.
I didn't make it. Thank you.
That's okay. I switched it, like halfway through the first lesson, talking about traces, because this is just a lot faster this way.
Yes, thank you.
So just to complete, this homework assignment, I'm going to copy and paste it into the next tab. When you copy and paste columns, it also preserves, the width of the columns, which is really handy. Except in this case, I have to remove, some of these things, and also change the initial value of x. Because in this case, if you look at the label of the sheet, it says y equals 5, which means I want that to be the outcome of executing the algorithm. So the question is, how can I make y equal to 5 when this algorithm is done. The only way you can do it is to change the value of x so that it is 3 or above. Okay, so 3 would do this trick here. So you still have to go to line 1. Line 1 is still evaluating this condition, but in this case, x is less than 3 is false. When the condition of a conditional statement is false, you go to the else branch. In this case, it is starting on line 4, or it is just line 4 itself. And line 4 is an assignment statement. It assigns a value of 5 to y. Y is now updated to a value of 5, and there's nothing else to do in this case. Post, and we're all done. So your homework assignment is similar to something like this, except you have a multi-branch conditional statement. So it will have, so you have to fill up each tab of the spreadsheet the same way as what I just did here. Okay? Yep, go ahead.
After you copied and pasted to the new thing, how did you delete all the stuff below that line? Exactly.
All I did was to select, okay, this is a click, and then I press the shift key and then click again to select a rectangular area in the spreadsheet, and then I just press the delete key to remove that.
Oh, okay.
Or you can use right click and then use delete content. Yep.
Nice.
Okay. Any other questions? That's one disadvantage of a screen recording is it does not record how I did it. It shows you the result on the screen, but it does not record what I do on the mouse or the keyboard. There was another question? Go ahead.
Yeah, on the homework, it's x is less than, and then it has the less than sign, and then it goes x is greater than 3.
Okay, that's
signs it like this. What is that?
Well, you have to. I can answer the question. I really like to answer the question, but I want you to study. It is in the conditional statement note. We went over that kind of quickly, but you kind of have to read that part too. Okay. So the next thing I want to do is to create a folder for today, so I can save everything into this folder. It's 2011-09-06, and then I'll save this document into that folder, so you guys have a quick and easy way to refer to it. Sample homework. Okay, that's it. All right. So now you have 2 homework assignments outstanding. One is due on this Thursday, and the other one is due on next Tuesday. That one is about while loops. We have not talked about while loops yet. We'll start to talk about it today. Remember the brain teaser from last time? What is the answer to the brain teaser?
What was it?
The brain teaser was I gave you a loop, and I was asking you what would happen if I were to execute that algorithm.
Oh,
Let me see if I can still find it here. No, it's not here. Oh, okay, well this is a good time to show you another thing that I have done. Some of you have reminded me to do it, so thanks to those of you who reminded me to do it. When you look at these items inside topic 2, some of these is like 2011-09-01 files. When you click it, it's a zip file, and with a zip file in Windows you can just open it. What it is a folder of the files that we worked on that particular day. So these are the files that I saved on September 1st during the class. In other words, if you just want to look at the algorithms that we worked on, you don't have to go through the entire screen recording, and then do your own typing, because you can just download the document and work with the document. It is not important right now because most of the algorithms that we work on are fairly simple. The traces are really simple too. But as time goes on, things will get more complicated, and these documents will become more and more useful. So in this case, I believe it is this one that I'm working on. So we'll go ahead and extract it first, And what we'll do is we'll extract it into today's folder. And where's today's folder? There. Oh, okay, cannot extract this archive type. The application to support this is missing. I did not include the unzip. Well, I don't know. Let's try that again. No, it didn't. It did. Okay. It did distract. Unzip it. Now I just open it again. Okay, this was what we traced last time. Okay, this is the algorithm that we were working with. Do you guys still remember this?
Yeah.
The repeat until loop. With a repeat until loop, one of the characteristics of a repeat until loop is the body of the loop has to be performed at least once. You cannot skip the first time. It will always be done at least once, and then you ask the question, do I want to do it again? Okay? And the question was, this is one of the traces. If x starts with a value of 3, this is what happens when you execute the algorithm. So this one was not too big of a deal. You know, we kind of know that it will go till 3, 4, and then 5, but when it gets to 5, we get out of the loop because the algorithm says that x equals 5 is an exit algorithm, is an exit condition. But when you look at, well, okay, I forgot to put it in. What if x starts with a value of 5? That's the question. So let's find out, what the answer to that is, because that was the brain teaser of last week. So I'm going to use sheet 3 for that purpose, and I'll do the same trick here. Copy all 3 columns, and paste it into sheet 3. Except it gives me some empty columns here, which I can also delete. Empty rows. Okay, so we want to start with this condition and find out what the algorithm is going to do. This is the algorithm. This is my initial condition. Where do I go next? We go to line 2. Okay, we technically do not go to line 1 because line 1 doesn't do anything. It is really just a label to mark the beginning of the loop, and there's nothing to do, and as a result, I do not trace the execution of line 1. So we go straight to line 2. What do you think line 2 is going to do?
And 1 to 5.
It's adding 1 to x, and x becomes 6. Very good. And then we have no choice but to go to line 3. Line 3 doesn't change x at all, but it does evaluate a condition to see whether x equals 5. So in the comments column, we have to say x equals 5 is either true or false. Is it true or false?
False.
It is false. So where do we go next?
2.
We go back to line 2, because remember, the condition x equals 5 is called the exit condition. If the exit condition is false, we have to go back and perform the operation again. Now what would happen to x on line 2? It becomes 7. We go to line 3. Does 7 equal 5? Nope. We go back to line 2. It becomes 8, and so on. Right? Yep, go ahead.
Basically, we said the mathematicians, you cannot 5 plus 1 cannot be equal to 5. You'll never get the answer to be 5. Because you always
No
add
value
1 to
greater
5.
than 5 equals to 5. That's mathematically speaking, that's it. Okay, so this is called an infinite loop. Okay, because if you continue to trace this, what will happen is this will go from 8 to 9, 9 to 10, 10 to 11, and so on and so forth, and it will never go back to 5. Or will it? Okay, now that's a very interesting question. It's a trick question. Okay, and that's why this is called a brain teaser, because first of all, you have to realize that, theoretically speaking, this is an infinite loop. Except in reality, it is not an infinite loop. It does get out. Okay, so here's the question. How can, when you increment a number, it starts with 6 already. How can it ever go back to 5 when all you're doing is adding 1 to it? That's the question. Well, to understand that, you have to understand how numbers are represented in a computer. Okay? Now, how do we call computers these days? They're called digital computers, and more importantly, they're also binary. Okay? Everything inside the computer are binary, which means they're represented by zeros or ones. Is that okay so far? Have most of you heard of that, of a modern computer? Okay. So with binary computers or digital computers, we can only allocate a certain number of bits, binary digits, to represent numbers. A binary digit, also called a bit, is just a 0 or a 1. We normally deal with digits. Okay, we normally deal with decimal digits, which means each digit or each place of a number can go from 0 to 9. In a binary number, it can only go from 0 to 1. But regardless of the base, this is called a base, base 2 versus base 10. But regardless of the base, if I tell you that I can only represent numbers using a fixed number of digits, don't you think that if I keep incrementing, I will hit a limit at some point? Right? I mean, that can be a huge number of digits. If I give you 100 digits, yes, you can represent huge numbers. But eventually, you will get to the maximum number or the maximum value that can be represented using 100 digits. If I add 1 to that largest possible value that you can represent using 100 digits, what happens to that number? Well, that's a good question too, because in some programming environments, it will generate an exception because the computer says, okay, there's no way to represent the next number anymore, and it is a bad condition. This is a bad situation. But when you program in C, it does not happen. When you program in C, it will simply wrap around to the smallest possible value that can be represented. Okay? And then it goes from there. So you're starting with the least value that can be represented using 100 digits, and eventually it will get back up into 5, and then your loop will exit. Okay? I know this is a little bit early to describe this, but I will throw that out anyway. If you can absorb this information, it's great. If you cannot, don't worry too much about it at this point. With a binary number, you can look at it as a circle, but there are only 2 marks. It's either 1 or 0. Okay? When you increment the number, you're turning it one way. When you decrement the number, you're turning it the other way. And there's a marker here. Okay? There's a little marker here to indicate the current value of the number. When you have 2 bits or 2 binary digits, then you have a wheel. But on the wheel, there are 4 markings now, because you can represent 4 distinct values. It will usually go from 0 to 1 on one side, and it goes from -1 to -2 on the other side. But nonetheless, the number of possible values that you can represent is limited to only 4. When you add 1 to the number, you're turning the wheel counterclockwise. When you're decrementing, you're turning the wheel clockwise. Okay? So what that means is if -2 is already here, and that will make 0 here. When you decrement from -2, it will actually become 0. If 1 is already here, and if 1 is here, 0 is here. When you increment from 1, it will just become 0. Is that right? No, I got it wrong. When you increment 1, it's turning the other way, it becomes -2. Okay? But we don't want to represent numbers using only 2 bits because it only gives you like 4 possible values. So what we want to do, inside most computers, we allocate 32 bits for each integer. Now 32 bits is a lot of bits, because what that means is you have a big wheel in this case, but I'll still draw it about the same size, because otherwise I won't have enough space in this classroom to draw that big wheel. It still works the same way. You start with 0. On one side, it goes from 1, 2, 3, and so on. On the other side, it goes -1, -2, -3, and so on and so forth. Except there are a lot of markings in this case, because with 32 bits, how many possible values can you represent? 2 to the power of 32. Is 2 to the power of 32 a large number? Well, it used to be. It used to be a large number. It is no longer a large number because it is only about 4 billion. Okay, it's 4 billion and something. Okay, but we can call it approximately 4 billion. 4 billion is no longer a large number. What is our national deficit? It's in trillions already, which is 1,000 times more than a billion. Okay, what is the world population? 6 billion something. So it cannot be represented by a 32-bit number anymore. So that's why I said, a 32-bit number used to be a large number, but by today's standard is no longer a large number. But nonetheless, we can just kind of go all the way down here. The largest possible value you can represent using a 32-bit number is 2 to the power of 31 minus 1. Okay, if you look at this value, which is 2 billion something blah blah blah, is the largest possible value you can represent using a 32-bit integer. What about the largest, or what about the most negative value you can represent? It is 2 to the power of 31. Yep.
When you download like Microsoft Office, you could download a 32-bit or a 64-bit.
That has to do with the operating system. That's a good question. We'll address that later. Okay, but that's a very good question. But nonetheless, there is a largest possible value that you can represent, and there is a most negative value that you can represent. It is limited. And the whole thing is a wheel, it's a circle. So when you cross over, when you increment from the largest possible value, what happens is you end up with the most negative value. When you decrement the most negative value, you end up with the most positive value. And that's the behavior of how numbers work out in C, C++, and most programming languages.
Why is it minus? 2 to the power of 31 minus.
Because 0 already takes up one spot, and 0 is non-negative. In other words, we don't count positive versus negative values. We count non-negative values versus negative values. And 0 is counted as a non-negative value in computer programming. In mathematics, it is both. Okay, 0 can be counted as a positive or negative value. But in programming, it is counted as a non-negative value. Okay, so that's why this program here seems to be an infinite loop, but when you run the program, it is not infinite. It will take a little bit of time to go through 2 billion something numbers, but eventually it will get back to 2, and the program or this algorithm will exit. Okay. Are there any questions about this? No questions? How many people have some exposure to binary? Go ahead.
Is there a way to see that in action on a computer?
Absolutely. Now, we haven't really talked about how to convert this to C code, but I can do it in C. That's a good question. It will also give you some exposure of how to write a program in C and how to run the program in C. And I'll just go to today's folder too. So everything that I talk about today will be in today's folder. Oh. Folder is just that. Okay. This is my favorite editor, which is Vim. But all programs, or most programming languages, will write programs in plain text. In other words, if you don't have a specialized editor, Notepad will work just fine when you're writing a program. Okay, at least as far as the source code is concerned. So what I'm going to do is to write a program, doing exactly that. Don't worry about this part here. This is how I say, I want a variable with the name I, and it has to be an integer. But instead of repeat until, C only has do while. When you use do while, the condition has to be exactly reversed. It has to be reversed. Yep.
So it would be like do while x does not equal 5 in your earlier thing?
Correct. Yep. So this will be x I does not equal to 5. And we want I to start with what? 5. And then inside the loop here, we say I gets I plus 1. Now remember, this is C code. This is not our pseudocode anymore. And you can also see that this is not equal to in C. It's just a lot more tricky when you express expressions in C instead of our pseudocode. But this program has exactly the same meaning as our pseudocode. Let me just display these side by side. Because what happens here is when you specify repeat until x equals 5 is called a exit condition. You get out of the loop when that condition becomes true. When you specify a while loop, a do while loop, this condition is the condition that needs to be true to stay in the loop. In other words, if you look at the C code here, it is the same as saying do I gets I plus 1 as long as I does not equal to 5. Are these two loops the same?
Yes.
One says, repeat x gets x plus 1 until x equals 5. The other one says, do I gets I plus 1 as long as I does not equal to 5. Are they equivalent?
Yeah.
Yes.
They are equivalent. Okay. So here I save the file, which is just a regular text file. A computer does not understand C natively. Yes, go ahead.
Where are you going to put in the line to print out what I?
Doesn't matter. The program will exit. The prompt will come back to me when it's done. So I don't really need to print anything. Okay. So what I'll do. Okay. When you look at this program, the question is, will it ever get out of the loop? If it does not get out of the loop, then the program will never stop. And if the program never stops, then the prompt, the command line prompt will never come back to me. Okay? So that's how I can tell whether the program is exiting or not. To make the compiler happy, I need to do this. All right. So next, we need to compile a program. Now this step is completely artificial, and we don't have to do it in this class. And the reason why we have to quote-unquote compile a program is a processor, like the Pentium processor, can only natively understand machine code. Do you guys still remember when we talked about machine code in the first class? Machine code is basically huge long binary numbers, and each one represents a very basic operation that your processor understands. It does not understand what is a while loop. It does not understand what is a variable. It does not understand all of those high-level concepts. In other words, when you look at this program, there's nothing in this program that your processor can natively understand, which means you have to have a translator to translate that into the code that your processor can natively understand. That tool is called a compiler, which is basically a interpreter, doing the interpretation. Yep.
And the compiler turns it into assembly language? Or
It turns
what's
it into
that?
machine code. It turns it into machine code.
Okay.
So I can now specify the output to be infinite, and I give it the source code like that. Now this part you don't have to remember, because in this class, this is only here to show you, the process of compiling a program. The compiler does not complain, and I can now run the program, which should never come back, okay? So we'll see whether it comes back or not. So far it seems like, I was wrong. The program seems to keep going and going. So what we'll do is we'll switch back to, oh, it just returned. Okay, it got out of the loop. And the reason why it got out of the loop is because when you look at a 32-bit number, the values they can represent is finite. But not only that, when you cross this border, the largest number becomes the most negative number. And then from the most negative number, it works its way all the way up back to 5, and then the loop gets out. Okay. Now this seems to be something that is unrelated to this class, but it does. Because when you write your actual program in cisp300, what you think would be an infinite loop is no longer an infinite loop. Yep, go ahead.
What if you say I equals 5.1 to start?
Well, since I declared I as an integer, I cannot say that.
That's what I mean, huh?
Yep.
Okay.
If it is fractional, then there's no way to go back to that value.
Okay.
Well, it does go back to that value. And it has to do with how 5.1 is represented in binary. Okay. In other words, there are only so many fractional numbers you can represent in the computer as well. So eventually, it will exercise all of those, possible values, and then, it will hit, 5 exactly. It will take a long time, but it will get back to 5 exactly. Well, maybe it will cause an exception before that happens. So the program would actually crash out in that case. Okay, any other questions about this? Yep.
On the trace itself, when you get down and it continues on the loop, how would you list that to engine?
You don't. You just say,
leave it like
you
that?
just have to indicate in the comments and say this is an infinite loop. Yep, you just say it's an infinite loop, and I understand that, and that's the end of it. Any questions about this particular brain teaser? No questions? Okay. Now is a good time to go back to loops here. We have just gone through all the repeat loop. Now the reason why a repeat loop always takes one step, or at least perform one iteration, has to do with the shape of this trail path here. You're coming down from the top, but you don't have a choice but to perform the operation in the loop at least once. It's only after you perform that action you get a choice. Do I get to get out when the condition is true, or do I have to go back to perform the operation again when the condition is false? So you always have to perform the condition. Always have to perform the action at least once. And there are many cases where this is inappropriate. This is not what you want. Let me give you an example. Let's say you have DirecTV. How many channels do you get when you get DirecTV? Let's say we get a premium deal, super duper deal. 500 channels, very good. And let's just say, realistically speaking, out of the 500 channels, you only like to watch one. Okay? And that's realistic as well, right? And because you only like that one single channel, when you turn off your TV, your DirecTV is already on that channel, right? Now, let's think of it, let's change this program here. Instead of take a byte, it is pressing the up channel key once. All right? Instead of 1 is full, we say this is the channel that we like. Okay? In other words, the loop becomes repeat, press the up channel key until I'm watching a channel that I like. Is that okay so far? I have a problem with this. Because before the loop, before I get in here, if I am already watching the only channel that I like out of the 500 possible channels, what do I have to do? I have to press the up channel button once. Because I don't have a choice. So once again, it becomes this problem, right? Because the 500 channels is a big wheel. If you keep pressing the up channel button, you will go back to the channel that you liked, but then you'll be serving all 500 channels, or 499, before you get back to the one that you like. What is the source of that problem?
Where you are first.
Exactly, you don't have a choice when you perform the action the first time. Okay, when you come in here, it doesn't give you a choice to say, oh, but wait, I'm already watching the channel that I like. There's no need to press the up channel key. It did not give you a choice to get out of the loop before you perform that action. So that's why, sorry?
Conditional statement before it.
Sorry?
You put a conditional statement before it.
Initial statement?
Conditional.
Sorry?
If channel.
Yes, you can put a conditional around the entire loop. But we have not talked about nested statements, so that's exactly the right solution if you don't have a while loop. Okay? So what we need to do is to use a while loop. So let's not deal with the text of a while loop. Instead, we'll look at the shape of a while loop. It looks more complicated, but it's actually not that complicated. A while loop looks like this. This is starting to look more and more like a biology class, right? The digestive tract and stuff like that. You don't really want to loop, in your stomach either. That would not be a very good idea. Certain animals do have a loop. in their digestive tract. We don't want to think about it. Okay, so in this case, you're coming in from the top, and this is a merge. Okay, this branch is a merge here, merging with this branch. So you don't really have a decision to go this way. However, at this point here, you do have two paths to go, and you can use a question, use the answer to a question to decide whether you want to go perform an operation or whether you want to get out right away. In other words, a while loop tests the condition first. It tests the condition before performing an action. And therefore it is, sorry, go ahead.
Well, it doesn't have to run the program versus the other loop.
Correct. You can avoid even one single iteration. And that's why it's called a pre-checking loop, because we check the condition before we perform the action. So in this case, if I were to use the channel serving example, then it would be this condition here. Whoops. This condition here will be this channel is not what I like, will become the condition. If the channel is not what I want, which means the condition is true, I will go here and I will press the up channel key, and it will go back to reevaluate, is this a channel that I want to watch? And it will keep doing this until this is the channel that this is not the channel that I want to watch, is false, which means it is the channel that I want to watch. And because the condition becomes false, then I will follow this branch here and get out of the loop. Are there any questions about the basic construction of a while loop? Does everybody understand how it differs from a repeat until loop? Basically, okay. So what we can do now is to take a look at some examples. Okay, this is I'll use an example to illustrate a while loop. So, and I have to be careful not to do your homework assignment either. Because your homework is really easy, and so it's very easy for me to actually do your homework assignment without realizing it. So I'm going to make more complicated examples in the class because your homework assignment is actually easier. Okay, so we'll go with like 10 here, and it will say while I is greater than 7. Do I gets I minus 1 while, and then remember to use indentation. The indentation does not seem to be very important at this point, but as we start to use nested statements, it will become more important. All right, so we have a loop here. The algorithm is here, and we're going to trace it in the second tab, or the second sheet. Just like with a conditional statement, as long as we have conditions to evaluate, we have to have the comments column. We need a line number column, and also one column for the variable I. The line column doesn't need to be this big. The I column can be even smaller. And we start with the precondition. In this case, it doesn't matter what I starts off with, because the first line is going to overwrite the value of I. So I'll just say that I assume nothing from I. I can be anything before I get into this program. On the first line, I gets initialized to 10. On the second line, on line 2, I have to evaluate the condition to see what I'm supposed to do next. Okay? I is greater than 7 is the condition I have to evaluate. What is the answer? Is that true or not? It is true. Very good. If the condition is true, where do I go?
3.
We go to line 3, and line 3 is decrementing the value of I. I goes from 10 to 9. Then I go back to, then where do I go? Now this is very important, because every year, every semester, someone is going to confuse a while loop with a conditional statement, because they look similar in some way, because you have a condition and then you have an action. But here is the big difference. With a conditional statement, after you take one branch, what do? You get out, right? With a loop, after you perform an action, what do? You go back. Okay? If you look at the picture here, after you perform the action, you don't get out. You simply go all the way back to the beginning, and then you evaluate the condition again. This is very, very important. So what we need to do with our example is, which line am I going to? Go back to line 2. This is very, very important. This makes a loop a loop. And we reevaluate the condition. This time, what am I comparing? Which value am I comparing to 7?
9.
We're comparing 9 because I has been updated to 9 now. But it is still greater than 7, so the condition is true. As long as the condition is true, we go to line 3. Line 3 is going to decrement it again. It becomes 8. Then we go back to line 2. 8 is greater than 7 is true. We go to line 3 again. It decrements to 7. Then we go back to line 2. And then we say, is 7 greater than 7?
No.
7 is greater than 7 is false. No, that's false. 7 is not greater than 7. Now, when the condition is false, we take the false branch, which takes us all the way out of the loop. So that's exactly what we need to do here. After line 2, we just go all the way to post. Line 4, I do not trace line 4 because line 4 is also what I call a marker line. It is simply there to indicate the end of the loop. So there's no point in executing line 4. Okay. Are there any questions about this trace? No questions? If anyone has any problems, understanding what while really means, just change it to as long as. So every time you see while blah 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 do and then end while, just look at it as long as, because the word or the phrase as long as means keep doing something as long as a condition is true. So in this case, it's the same thing. So this really is as long as I is greater than 7, I gets I minus 1. So you keep doing I gets I minus 1 until I is no longer greater than 7, then you get out of the loop. Any questions about what I just did, the example? So it's a good time to look at your homework assignment for next Tuesday, which is closely related to this.
Instead of using while, we can use as long as? Instead of using while, we can use as long as?
You can understand it as long as, but I always write it as while because that's what most programming languages use. But it really has the same meaning as long as. Okay, you can see this is your homework assignment. Instead of decrementing, we have incrementing. Instead of comparing that I is greater than some value, it is comparing that I is less than some value. So what you need to do is to go to sheet 2, which gives you a precondition, and trace it. Go to sheet 3, trace it. Go to sheet 4 and trace it. And there are only 3 cases in this case. And then when you're all done, save the file and then turn it in. Are there any questions about your homework assignment that is due on next Tuesday? How long would that take you? 10, maybe. But it's not complicated. It's just, can you follow the code? Okay? Now, why am I emphasizing so much that, to make sure that you guys can follow the pseudocode that we have talked about in the class? Isn't it not enough that you get a rough idea or gut feeling what the program is supposed to do? Yes?
Computers never do that.
Computers never do that. Well, yeah, well, that's true. But if the objective is to say, what happens to this algorithm, how come I don't ask just, what will I be when the program exits? But how come I have to make you go through all the mechanical steps to execute a program as if you are the computer?
It's important for debugging.
It's important for debugging, exactly. Okay? When you are writing programs, you don't want to be creative. Okay? There are certain portions that requires, some creativity, but as far as debugging is concerned, you don't want to be creative. Okay? You want to be logical and analytical and mechanical. Sometimes you look at some program, it looks like the program is going to do blah, blah, blah. You don't want to think like that. You want to actually read the program, read the code, and know exactly what it is going to do. Okay? And apparently programming is also boring. I have done my own dozing off in the class, so I cannot complain. I'm always sitting here, like the front row seat, dead center in the whole classroom, and I'll be dozing off. And I can tell exactly when I doze off because I used to take notes using a fountain pen, and I can see, and I would drool, so I can actually see, I can see where it lands, and it go like, oh, okay, so that's where I started to lose consciousness, and and I lose my notes at the same time because I cannot really read it after that. So that's why using pencils would be better. Okay, so we are done with while loops. Are there any questions about while loops? Okay, so one is called a pre-checking loop. The while loop is called a pre-checking loop because you test the condition before you perform the action. So what do you think is the other name of a repeat until loop? It's a post-checking loop. Okay, because you check the condition after you perform the operation. Okay, now the order of the introduction of the loops is I introduce repeat until first, and then I introduce a while loop. And the only reason why I pick that order is because we are more used to the words repeat blah 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 until blah blah blah. Okay, that's the only reason why I pick that order. When you're writing programs, guess what? Most of the time, you should use a pre-checking loop instead of a post-checking loop. I can give you one example where you have to use a post-checking loop instead of a pre-checking loop. Okay. Look at this code here. Repeat, ask user to input a zip code until the zip code is valid. Okay? Look at this code here. It's a repeat until loop. Okay? Why do you think in this case I cannot turn it into a while loop?
Because as soon as they click the input, it would like say it's wrong. It's checking before you can input.
Exactly, because you'll be checking before there's a zip code that the user enters. Exactly, that is exactly why. So in this case, the condition that we are checking is the result of the action inside the loop, and that's why it makes sense to be a repeat until loop. Now, if I want to convert this into a while loop, it would look like this. We'll say while the zip code is invalid, do ask user to input a zip code, and while. But the logic is no longer the same. It is no longer valid. Okay, it's no longer correct. Because if I say while the zip code is invalid, what zip code am I talking about? This is happening. I'm checking the validity of the zip code before I ask the user to input the zip code. So the zip code that I'm checking the first time is just some value floating around in the system. And that's why in this case, it does not make any sense to use a pre-checking loop. It makes sense to use a post-checking loop. Does everybody understand this part? Now there is an easy fix, okay? There really is an easy fix to this problem. Because what we can do is we can just say, oh, we can just duplicate this line here. We'll just add one more line before the while loop and say ask user to input a zip code. Because if I did that, then the comparison or the condition of the while loop will check the zip code of something that the user inputs to. But why don't I want to do that, even though it is now equivalent to the other one?
If you need to make a change to the process of asking a user, you now have to debug another line of code.
Exactly. I have to make sure that I also make changes to the other line if I make changes to the way that I ask a user for a zip code. In other words, if I have a way to ask a user to input a 5-digit zip code versus the 5+4 zip code, if I change it here, I also have to remember to change it to the line before the while loop. And that's not good, okay? Because it makes it easier to introduce bugs in a program. As a general rule, if you're going to copy and paste in programming, you should think about Well, do I really have to copy and paste? Because copy and paste means if you make a mistake before you paste, you'll be pasting that mistake all over the place. And then you have to fix that mistake all over the place too. So we don't want to do copy and paste unless there's no other choice. So we'll get back to copy and paste later when we start to talk about subroutines. Are there any questions at this point about loops? So I use the same example here. Okay, you're basically explaining why sometimes it makes more sense to use post-checking loops, even though most of the time you want to use pre-checking loops. So we are done with loops at this point. And as I said, this class does go fast if you don't ask questions. So we are done with loops. We are now moving on to nested statements. So nested statements has to do with the hierarchical structure of programs. Okay, so let's go ahead and take a look at that note. So the question is, why do we want to use nested statements? Now, if we don't use nested statements, what that means is you can only have a conditional statement, but inside the conditional statement, you cannot have any statements except maybe for assignment statements, because assignment statements are really the lowest level of statements. It also means that in a loop, you cannot have any other loops or conditional statements. Okay, that's what it means when we cannot have nested statements. We already explained, the equivalence of the lack of hierarchy or structure when it comes to the file system. It is the same as saying, well, I'll give you a 2 terabyte hard drive, but you can only have one single root folder. C:\/ is your only folder. Right? Well, it doesn't make any sense because you cannot organize anything now. But in the case of programming, it's even worse because it simply won't be possible to do things that we need to do if we don't have the ability to contain one statement in another. Okay? So here's an example of a statement that is already nested. Okay? I never refer to it as nested because we never really talked about nested statements. The reason why it is nested is, well, let's count how many statements do we have here. We have 4 lines, but how many statements do we have? We have 3 statements. Okay, we have exactly 3 statements. And in this case, let me see how I can. It's a little bit harder for me to. I suppose we can do this. I used to have a tablet PC, just for situations like this. And we'll go ahead and see, how do I get import bitmap? Come on, let me move it. Okay, no. All right. So this is the 4 lines that we are talking about, and I was asking how many statements do we have? Let's go ahead and highlight all the statements that we have here. Okay. And then we have, that's one statement. That's an assignment statement, right? And here's another assignment statement. So that accounts for 2 statements. Where's the 3rd statement? The loop itself is a 3rd statement. So the 3rd statement goes from line 2 to line 4. It completely contains line 3 as a statement inside it. Okay? In other words, if you want to look at this as files and folders, I'm counting the number of objects in the file system. We have a file here, we have a file here, and then we have a folder here. A while loop is kind of like a folder. Why is it like a folder? Because it can contain other objects. It can contain simple stuff like assignment statements. Assignment statements are like files inside a file system. Why do you think that I compare assignment statements to individual files? Because it cannot contain anything else. Okay? An assignment statement is an assignment statement. It is atomic. It cannot be broken up into smaller pieces. On the other hand, if you look at a while loop or repeat until loop or even a conditional statement, it can contain additional components. It can contain another conditional statement. It can contain another loop. It can contain assignment statements, and so on and so forth. So that's why in this case we have 3 objects. We have 3 different statements. It's just that one of them is a folder. It can also contain additional items. So let me save this file in today's folder, and we'll call it the same thing, simple nested. And it is saved as a SVG file. I think Firefox knows natively how to open an SVG file. Any questions about this example? Nope. Okay. What about a more complex example? Something like that. This is nothing complex, trust me, this is not complex. Okay? It's only here to illustrate the whole point of nesting, or in this case, we have a loop inside a loop. Okay? So what we'll do is we'll trace this algorithm to find out what it does. Now, I really don't have to do this because the rest of these nodes, well, first of all, there's a big picture of what that loop looks like. And guess what? There's also a trace already, a partial trace. It's not complete. So I could have just repeat or just read my own notes here, but that would be absolutely boring, and we don't want that. Well, I don't want that. I don't care about you. Okay. Well, let's do it step by step. That's the whole point. I cannot. This is a bitmap. Yes?
Just as a reminder, don't forget about roll.
Ah, very good. Because some people need to add to the class. Let's do that first. Go. Okay, we'll leave this one here. Unfortunately, since I did not take my roll sheet, I will have to take roll in the class, and that will take up some time. Someone's going to say, "Oh, that's good. Finally we can breathe." 2011 09 06 roll. All right. Okay, thank you. Is all right. Thank you. Good. Okay.
Here.
Okay, thank you.
Here.
Wade. Okay, thank you.
Here.
Thank you.
Here.
Thank you.
Here.
Timothy.
Here.
Okay. Oops. Jennifer.
Here.
Okay. Here. Michael.
Here.
Aaron.
Here.
Thank you. Isaac.
Here.
Thank you. Alexis. Thank you.
Here.
Dean. Miguel.
Here.
Jordan.
Here. Here. Here.
Thank you. Brianna. Not here. No, you're not Brianna.
No, you're
Next one.
sir.
Yes. It's good to look ahead. It's okay. Vadim. Okay. Brett. Okay.
Here.
Thank you. Christopher. Not here. Andrew. you.
Yep.
Victor, you. William, Brian. Is Brian Miles here? Nope. Dylan?
Here.
Thank you. John?
Yeah.
Sean? Thank you. Matthew?
Here.
Thank you.
Here.
Patrick?
Here.
Okay, thank you.
Here.
Thank you.
Yeah.
Where?
Yeah.
Okay. Anthony? Thank you. Daniel? And Jimmy?
Here.
Carrie? Junwei? Michael?
Here.
Jeremy?
Here.
Farnham? Maybe I should make the default absent so that you guys would pay attention. It's like, no, no, I'm here. Okay.
Here.
Cody? You?
Here.
Hong Su? Okay. And Jay?
Here.
Thank you. Oops. Ooh, I almost missed that one, huh? Okay, well, I already sent email to 2 people on the wait list, to say that you can add to the class. So if you receive a message from me, just go and get an add permission. I don't think the permission number will work at this point, so you will need to bring me a little slip of paper to add to the class. All right, so that was not too painful. Now we can go back to this, painful stuff. Well, it only looks painful. It really is not that bad. Let's see. We'll get rid of some of the tabs that we don't need anymore. And this is untitled. Why is it untitled? Oh, okay. Save it first. Almost your homework. And here we have our code here. So I just need to type it in as quickly as I can. And this is also a good, opportunity to see the effect of the lack of indentation. And I'll intentionally do this without indentation for, well, I guess the first few times. Okay. So you can see the differences between what I just typed here without indentation and the actual code on my website with indentation. What is your feeling right now? Which one do you think is a little bit easy to follow?
Indentation.
With indentation? Because with indentation, I can tell right away which statement belongs to which loop, okay? The other one, I can tell, but I have to read it more carefully, okay? So let's try to do this without indentation for a little bit of time, just so that we appreciate the value of indentation, right? Okay. Well, that's really an important part of this class, is to explain why we need certain things. I mean, otherwise I'll just be telling you, oh, you need this, you need that, but why? Well, we'll see what happens without. It's the same thing with my kids, but why do I have to? Okay, let's do it without. All right, okay, so here is our loop. The precondition is, let's just say that we know nothing about these 3 variables. Okay, we go to line 1, that's easy. Line 1 is just evaluating the condition on, the value on the right hand side, and then change the variable on the left hand side. X gets a value of 0, easy. Line 2, same thing, except we change a different variable in this case. Line 3, still easy because we are just evaluating the condition of a loop in this case. This is a pre-checking loop. So we say x is less than 3 is true, 0 is less than 3 is true. Then we go to line 4. Any questions at this point why we're going to line 4? No? Okay. Because the condition is true, we go into the loop. We are now on line 4. Line 4 is putting a 0 into y. So column E gets a value of 0. And then we go to line 5. Any questions why we go to line 5 from line 4? Because they're sequential, right? Because line 5 follows line 4. So there's really no question why we have to go to line 5. So there's nothing really truly interesting at this point. Y is less than 2 is true. Okay, so far so boring. Line 6. Line 6. Now, are there any questions why we go from line 5 to line 6? Why do we go from line 5 to line 6?
Because
Go ahead.
There's no thing saying go back to the.
No, well, but this is in the loop here. So we go from line 5 to line 6 only because the condition of the pre-checking loop is true. Okay, so you gotta know why we go from line 5 to line 6. It's not because they are sequential, but because the condition of the loop is true. Okay, so gotta make sure that we remember that. Line 6 is adding 1 to y. Okay, fine. Y goes from 0 to 1. We go to line 7. Line 7 says we have to add up all 3 variables and then store the result back into S. Okay, S is 0, X is 1, Y is 1, 0 plus 0 plus 1 is 1. And then we store that back into variable S. Now, where do we go?
Line 9.
Sorry.
Well, this is where indentation starts to become useful because we are at the end of the action of a while loop, right? And remember, a while loop, a pre-checking loop, is not a conditional statement. At the end of the action, where do we go?
Which while?
We got to go back. Aha! That's a good question too. Which while am I talking about? Well, because there's no indentation, it becomes kind of difficult to tell which loop we are in. Okay, so that is why that's why indentation helps. Now let's just say that I don't want to deal with indentation. Is there a way to figure out which loop we are in? In other words, we are on line 7 right now. Okay, in terms of here, we are on line 7 right now. So the question is, I know this is the end of a loop. I just performed the action of a loop. But where am I supposed to go? Where is the beginning of this loop? Go ahead.
the second, because the middle is like the inside, the outsides.
Exactly. So which line am I going back to?
Five.
We are going back to line 5. Okay? Now just because you know you're at the end of an action inside a loop and you have to go back to the beginning of the loop, doesn't mean that we know where to go back to. Because there are 2 loops here. We can go back to line 5, or we can go back to line 3. Or it seems that we can go back to line 3. But that is not the case, because if you look at while as an open parenthesis, then end while is a closed parenthesis. So when you get to the closed parenthesis, you have to go to the matching open parenthesis to potentially perform another iteration. So that's why from line 7, we do not go back to line 3. We have to go back to line 5. Is that okay so far? Okay.
But why do we go back? What number are we trying to find?
This particular algorithm has no particular purpose.
So then we're just going to be going on forever.
No, it won't be forever. It will just be a long time, but not forever. Okay, so on line 5, we're evaluating y is less than 2. Is that true? Okay, it is still true. We go to line 6. Line 6 is going to add 1 to y. Y goes from 1 to 2. Line 7 is going to add up all 3 variables. We have 1 plus 0 plus 2, which gives us 3. We store it into column C because that's where variable S is. And then where do we go?
Back to 5.
Back to 5. Very good.
That's false.
Okay, we go back to line 5, and this time it is false. Now we know that when the condition of a pre-checking loop is false, we have to get out of the loop. In other words, we have to get to the line after the end while. But we have, where am I supposed to go?
9.
We know that we have to go to line 9, but it did take you a little bit of time to search, to visually search for and while, didn't it? Okay, question?
Yeah, but x is still less than 3. That don't
It doesn't matter because line 5 is checking only whether y is less than 2. So this is the whole nature of nesting, because you're just spinning around in the inner loop, before you get out and go back to the outer loop. Okay. So from line 5, we go to line 9 in this case. So this is a very important transition. We don't get out of the program because we only want to get out of the inner loop. Okay? Now, I'm pretty sure some of you have already started to realize that without indentation, you have to scan through the lines in order to find, okay, where's the end while, right? Now, if there are multiple layers of code, then it's not just a matter of where's the end while, because you also have to count the while and the end whiles in order to locate the correct end while. Okay. So let's go back here and fix it up a little bit, okay? So I'll show you some tricks to control the nesting or the indentation. You can do this, okay? I click here, I do a shift click here, and I have now selected a block. I can now indent the entire block of code here. And the same thing, I can select this, shift click here, and then I can also indent this entire block of code. I mean, how is it different now compared to before? It's a lot easier to find the matching end to a while, okay? Why is it easier to find a matching end to the beginning of a loop? Because they have the same indentation. Okay, so visually, you can see that line 5 and line 8 are related. Line 5 is the beginning, line 8 is the end. Visually, you can see that line 3 is the beginning, and line 10 is the end. It just makes it so much easier to see, how things are contained. Is that making any sense? In other words, you can actually, just visually tell, how things are nested. But this can only get you so far. Okay, we are running out of time. Imagine that you have a program, or you have an algorithm that has 500 lines. A single algorithm with 500 lines, with loops, conditions, conditional statements, and everything nested, all over the place. How do you line up the beginning of something at the earlier part of the algorithm to its own end, which is close to the end of the thing? It's not going to fit on one page. 500 lines, there's no way 500 lines will fit on one page on the computer. So what people used to do, yeah, go ahead.
Color code. Color code. IDE.
Sorry?
Use an IDE and color code.
You can use color code, but in the past, people did not have IDEs. So what they do is they print out that code in fan-folded paper. Have you guys seen fan-folded paper? Okay, they go zigzag, zigzag like that, so you can have a continuous printout. So 500 lines using 12-font font is going to take up, divided by 66, 8 pages or so. Okay, and then what they do is they get a long ruler. They get a long ruler. They line it up. Their table may not be long enough, so they would usually put it on the floor, and they use a long ruler to line it up. Okay? It's a bad idea to write an algorithm that has more than 30 lines. Okay? So 500 lines is completely excessive. So we'll talk about how to avoid writing programs that big. Okay? Algorithms that big. And don't forget your homework assignment, and I will upload the files and the video as soon as I can.
So on the homeworks, on the last else statement, it's just else. We should just totally leave that out.
The conditions,
In the trace.
if it is not possible, you just tell me it is not possible. Yeah.
No. I mean, it just says else.
You're talking about the one.
The very last thing, else, then do this.
Yeah. You're talking about the multi-branch?
Yes.
The else means, if all the conditions are false,
Right.
then do it.
Right. What I mean is, when we're doing the trace, we're not going to say anything for that line. This one.
In this one?
This line 7. But see,
Yeah, you
line
don't
3 and
trace
line
line
5 have
7.
something else on it. But
That's what everyone
okay.
says.
What
Yeah.
if I did? What if I just said we don't do anything
and there's a
here?
couple
because-
It's not a big deal, you know, because it really is the last one. It's just that, you know, I don't do it
write
in
them in
class.
here, it's gonna.
Okay.
But if you say line 7, then
Well, I
line
just-
8, you know, it's no big deal.
Okay.
I won't count it wrong.
Write them actually
Okay,
in this
that was my
notebook.
question, because I'll go
You can
fix it
make
if I need to.
photocopies.
No, that's fine.
And then
Okay, thank you.
It's,
Yes,
because
just a
the
question.
audio is working.
On the waiting list, I think I'm like
No,
number
it's,
2.
and then I
I'm
can
not
just.
sure.
show
Should I
you
just
the
check my
notes,
email
yeah.
to see if
Oh,
you sent me the email?
I just sent you
Online,
email.
you can.
So
He's
you are
already
going to
doing
be added to
audio,
the
it's not
class.
that helpful.
Okay, so then I would follow up at the next
Right,
class
right.
meeting with you
Yeah,
to
so I mean,
get the
I
code,
just
or is
figured
that, or is
test
that?
if you
Yeah, just,
know
I think you might need to get an
Wow.
add slip now, because, you know,
Yeah.
the permission
So do
number
you
may
want
be
me to,
too late already.
so what do you
But with a
want me to
slip,
do,
you know,
like
I can
write
add you
down
to the
kinda
class.
everything
Thank you.
that's on the screensaver, like pertinent?
I'll try and pull it.
Yeah,
try
I
and
mean,
you
pull
should.
it. Yes.
Okay.
I'll try and pull
diagrams
my
and
homework.
trying to write out what he,
Uh-huh.
Little,
like when he
I
traced
noticed there's
something,
no
Okay.
upload
just
button
kind
on
of the
there.
basic.
Which
So,
one
like,
are you
when
talking
he-
about?
When he traces
This one?
like,
This one?
just anything, you know, this
It'll still be there.
like for the first time and
When I
Right.
see
special
this,
instances.
Yeah.
Okay,
And
yeah.
maybe
This
like
button
jot down
called-
notes or.
You mean this
why.
one, right?
export, yeah.
Okay.
I don't know,
Okay, let
interesting.
me,
Yeah,
let me
that
log
would
in
help
as a
too,
student.
because
Have you turned it in once already?
Yes.
I'm not,
Okay, I might have forgotten to turn on the,
I don't have a requirement.
then people
to
turning in
take
again.
notes, then I'll
Easier.
probably just
Allow
go-
resubmitting
yeah,
is
just
true,
kinda hit back
so
in
you should
class.
be able to turn it in again.
Oh, cool, well,
All right.
thank you.
Let me
What was your
double
name?
check.
Drew.
Drew?
So
All right,
I'm
good
gonna
to
change
meet you.
my name
That's
to,
cool.
change my role to a
At some
student.
point, we can,
Go to multi-branch,
it doesn't have to be immediately, but
go
go to
to all the way to the
DSPS.
bottom.
Yeah.
And
Yep, it's still here.
sign a couple
But
things,
when I
and then
log
I'll
in,
pay you a
Mhm.
different semester.
those buttons not there.
So,
That's awesome.
Those buttons are not there?
Yes.
Cool.
alrighty.
Awesome.
Thanks. Are you enrolled in the class, you're still working?
Okay.
I'm gonna stick,
can't
I'm not
pretend to be you.
enrolled officially, but, I'm just gonna stick with it until
Log
the
in
end of the
as,
semester. They switched my physics class,
And
or they
so
actually
I'm
canceled
logging
my
as you
physics
right
class,
now.
which was
and
supposed to be
still
now.
here.
That's weird.
Yeah, try a different
Yeah,
browser.
different browser.
Yeah,
at
try a
this
different
time,
browser.
and
It
they
could
switched
be a
it to
browser
the
issue, but I
class
don't think
later
so.
on today.
And about the.
And,
Yep.
so I just added this class.
I need,
Added this one.
Gotcha.
So-
aside from Dean too.
Eventually,
I don't
I'm
think
sure
we need
enough
Dean's
people will
signature
drop
yet.
out and not show up.
So
Yeah,
my
I'm sure.
signature should be good enough.
I'm sure once people
Thank
this,
you.
this class is in.
On e-services, it shows that there's 4 seats available in the class.
Oh, okay.
So
And you are.
I'm number 4.
You're number 4? Okay, I'll add,
Oh,
I'll
I
add 2
checked.
more people.
Okay.
So I'll send the next 2 people on the wait list that have been coming to the class, you know, email. So
Okay.
you'll get a notification.
And it's the little slip that we need to bring
Yeah,
in?
just like, you know, what he brought me.
Like, where
you
do
know.
I get that?
Records and admission. Admission and records, yeah, which is
Okay.
in the admin building.
Okay, alright, thank you.
Yep.
I got this,
Something I watch
the
on YouTube. This
chemistry.
program.
Sorry?
Helping out with this
Nice.
program on
Yeah.
YouTube.
Which physics were you
Say
taking?
431.
not quite catching
Alright.
your question.
Yeah.
I've done the 410,
I would
420, but not the
This
31.
program on YouTube.
That's pretty cool.